we have set foot on the moon
It's one small step
and begun our research of other planets. And now, we are entering a new phase of space exploration. Artemis and other planned space excursions will take us to our moon and nearby planets. But what do we do when we get there? How will we survive? Outer space is extremely dangerous, and most space design is focused on survival. As we consider colonizing the moon or other planets, the stakes change. Such colonists need do more than survive. They need to thrive. Sega Space Architects are focused on making that a reality.
Sega is a small design and engineering company in Copenhagen that specialized in architecture for extreme environments. More specifically, architecture in outer space. We are very focused on the interior spaces, the lighting, the materiality, the spatial organization of space habitats.
Of course, optimizing for the human experience comes with challenges.
We kind of think the challenges makes everything exciting.
Sega begins with a unique design.
So if you look at it from the top, it looks like a triangle, or more precisely a pie. And that pie fits neatly together with 5 other pieces of pie to create a full circle. And that is dimensioned to fit very precisely inside a SpaceX Starship fairing.
Once on the moon, each of the 6 pie-shaped modules will be connected by a corridor.
Whenever we design anything for outer space, every single piece or hardware or whatever needs to have several purposes. So we always try to design something like a Swiss Army knife. So we came up with this elaborate, very complicated shell. And then, reality hits and you're like, okay, but we need to be able to manufacture this. In half a year, we need a habitat that actually sits somewhere and people can live inside of. And then I reached out to Ingersoll once I saw that they were probably the most promising candidate to 3D print something of this size and complexity.
Well, Ingersoll's response was immediate and with a lot of enthusiasm. It is one of those efforts in which the Ingersoll technology and the Ingersoll capability fits extremely well. Ingersoll was able to fast engineering this technology thanks especially to our long background, first in milling manufacturing and then in composite manufacturing.
Prototyping for us is everything. The benefit of 3D printing is we don't have to spend time making a mold. So we can actually make changes all the way to the day before printing it. And we actually did that. Once you have printed the entire habitat, you probably learned a lot, and then you can iterate it for the second habitat, again without creating a mold. And you can actually keep iterating.
Ingersoll's expertise in additive manufacturing was critical. It enables engineers to experiment with new designs that traditional technologies could not execute.
Sega came to us with a design that was highly optimized, and the topology was perfectly modeled for the forces that they needed it to withstand. However, some of the angles and things that they designed for were not very optimized for our 3D printing process. I think we went through a final of 8 different iterations with them.
We really engineered the shape together. It was a lot of intense meetings going back and forth. And then we also engineered the material. So the shape and the material needs to be developed together so it is 3D printable.
When designing for space travel, every pound matters. Sega and Ingersoll worked together to make the walls as thin as possible, while still being able to withstand the pressure.
It is the tallest 3D printed single-piece polymer structure in the world at 7 meters. And that was a huge undertaking. It is only 5 millimeters thick, so you want the topology optimization of the habitat structure to keep the pressure inside, but you also want something that's printable.
What Ingersoll is doing on that to print that lunar habitat is really a multi-headed system. What lends it perfect for Ingersoll for Cinemeric is not only the high precision, but the traditional type of manufacturing that's built in with the additive manufacturing. The Siemens system is a perfect foundation for you to build not only future systems, but really build upon so that you can do things in outer space compared to terrestrial applications. It's definitely a wonderful platform for them to build upon.
One of the things I really liked about this project was the new criteria and challenges that they presented to us. We typically print at 150 pounds an hour. We're extruding a lot of plastic, but they wanted finer detail, so we had to use a smaller nozzle. The other cool thing was they were able to get a specially designed material that has UV resistance.
Advances in large format printing will have many long-term implications for humankind, both in space and on Earth.
I 100% believe that the learnings that we make from working with outer space can benefit humans today on Earth. And I know that for a fact because we are doing that right now. For example, some of the spatial organization that we do in the habitats, because they are so small, will also help the housing crisis and the building crisis here on Earth right now today.
But for now, Sega continues to be focused on space.
So the first step is everything is printed and developed on planet Earth. So each habitat is completely finished as a standalone plug-and-play unit that is shipped in a Starship.
This becomes the foundation of a civilization that would be able to 3D print on the surface of the Moon.
The most interesting part is when we can 3D print the habitats on the surface of the Moon. You would send the 3D printer directly to the Moon and you would use the local resources, maybe with a little additives from Earth, but mainly the local resources, the regolith, the dirt on the Moon, and turn it into a 3D printable material. And then you only have to bring a printer, the tool, and you can print as many habitats as you would like.
Once you have the local printer and the technology is working, there are seemingly unlimited possibilities.
Every single thing we do on the Moon is because we want to extend the reach of human settlements. So the habitat is designed to work on the Moon, but it wouldn't take that many alterations or changes to the design for it to work on Mars. Many of the conditions are the same.
Pairing traditional manufacturing methods with design breakthroughs, Ingersoll and Sega are crafting new possibilities for the future of humankind.